Welcome back. Today we're going to talk about a couple of other triangle congruence postulates, angle side angle, angle angle side, and hypotenuse leg. First we need to have a little bit of vocabulary time. We need to talk about what it means to have an included side. So I'm going to draw a little triangle here. I'm going to label it ABC. And the included side, I need to reference these angles. So this is going to be, I'm going to outline angle A in blue, and I'll use a little purpley, magenta, pinky kind of thing here for B. And so if I denote this here, this is the included side. And an included side is included because it's shared between two angles. So the included side is the side by two consecutive It's the side shared by two consecutive angles. And so AB is obviously between A and B, so it's consecutive, it's shared. That being said, let's look at the angle side angle postulate. Just as with side 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 and side angle side, it has to do with the order of the letters. Angle side angle talks about two angles, and the included side of one triangle are congruent to two angles, and the included side of another triangle, and the triangles are congruent. Look at how this works. I'm going to notice that I have an angle, and here's the included side, and here's my other angle. So I have angle, side, angle, and over here I've got the same setup but a different orientation. So here's my angle, included side, and here's my other angle. Now notice, the important part is that they are congruent. So remember, these are congruence postulates. We're not trying to prove all 6 things, we want 3. In this case, it's angle, then side, then angle. In that order, they are congruent. So therefore, the conclusion is we could say that triangle ABC is congruent to, now it went from 1 to the one with none to the one with 2, so 1, none, 2, so D, E, F. That's how that works. So let's look at this angle side angle. I know the setup that I need. I need to have an angle, then a side, then an angle. Conveniently, so I'm talking about UVX and WVX. So UVX and WVX. Conveniently, they've marked an angle up here, and I want to look at some other information. So already I can say that the angles that are UXV is congruent to, so that's UXV is congruent to angle WXV, and that's given. Remember, I'm trying to prove 3 things here because I need angle, side, angle, so I'm trying to use angle. And I've got this other angle marked down here, so I'm going to say that because this is 90 and these 2 angles are a linear pair, I can also say that this is 90, right? So angle UVX is congruent to angle WVX, and that's the linear pair postulate. And it's a linear pair postulate because they're on a line, so they must both be, equal to 180 together, and one of them is 90, so the other one must be 90. It's linear pair postulate combined with angle addition postulate. So I've got my angle and my angle. Well, I need to ask myself, which side is included between those? It's the shared side. So here's the other side that forms my first angle. Well, that's not shared with anything. And if these are my 2 angles, I want to say XV is congruent to XV. Well, what property allows us to say that something is congruent to itself? When it looks in the mirror, it sees that that's what it is. So that must be the reflexive property of congruence, because that middle side is shared. And so I can say that triangle UVX is congruent to triangle WVX by angle side angle, or ASA without the dashes. You see how that works? So this included side and the two angles are what I need. See if you can try this one down here. So I'm going to say use line properties. Use parallel line properties. That should be properties. Okay, use parallel line properties to solve that one. Here's another one. And I've crossed it out, done a little doctoring. I mistyped it. It's the angle side. So as you can imagine, there's three pieces. One of them's an angle, one of them's an angle, one of them's a side. But in this one, it's a non-included side. Check out how this works. I've got my two angles, and it has to be not the one that's between them. So it's not the one that's between them. Let's look down here. I've got a couple of proofs here, and I don't want to do those right now. You can look over those. Try them if you want. We're going to try them in class together. So the angle side is the unincluded side. Hypotenuse leg. Hypotenuse leg is a variation of the angle side, except the angle, or I'm sorry, the angle side is something we can use. We cannot use side angle. This is the only case that it works. Okay, so in this case, I've got this 90-degree angle, and I have the hypotenuse and one of the legs congruent to right angle, hypotenuse, and one of the legs. So if that's the case, those three pieces in that combination, those can work to prove triangles congruent. Let's look down below here. Determine if you can use the hypotenuse leg congruence theorem to prove the triangle's congruent. If not, tell what else you would need to know. So VWX, so that's VWX, so it's the big one here. And I want YXW, so the two big ones that kind of face in. Here's what I'm going to do. I'm going to pull them out so you can see kind of what's going on here. Okay, so we've got this. Here's my 90-degree angle, so I've got VWX, and this side here. And I'm going to go with the other one this way to kind of give you a visual. Sometimes it helps me to pull them apart, because then I can see what I'm actually dealing with. YXW. Now my picture doesn't really give it justice, but let's look here for a second. I've got two triangles here, and I'm trying to use hypotenuse legs. So I know I'm going to need a 90-degree angle, which I have in each of them. I know I'm going to need the leg, which I have in each of them. Then I need to talk about the hypotenuse. So let me do a couple little proof statements here. I'm going to say angle V is congruent to angle Y, and I'm going to say both 90. And that's given. And I'm also going to, because that proves my 90-degree angle. So then I'm also going to say that side VW is congruent to side YX. That's given. So now I need to just say something about the hypotenuse. Well, let's notice about the hypotenuse. Here's my hypotenuse. Okay, it's also this one down here. Well, what do we notice about that? It's WX. And anytime we're trying to say that WX is congruent to itself, think about the property that we're going to use. Anybody? You got it. Reflexive property of congruence. Reflexive prop of congruence. Good. So the reflexive property of congruence gives us that those two pieces are congruent. So we can say by hypotenuse leg triangle VWX is congruent to triangle YXW. Okay? That's all there is to it, guys. So now we have 5 of these postulates. We've got the side, 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 angle, side, angle, angle, side, and hypotenuse leg. If you can remember the configurations for each of those, you'll be good to go proving triangles congruent. Thanks for watching. We'll see you next time.